Hi everybody, let's talk about units and unit conversions. For AP Physics 1, the units that we use to make measurements are really important. And I know that everyone that's taken chemistry has had some extensive practice here, so I'll just kind of go through this quick review session for you. So we'll be using the metric system. It's also known as the international system. And you probably already know the reason for this. The metric system is a base 10 system, so it's very easy to convert between units. And another idea is because, especially today, scientists and engineers are really working globally. When we think about what's going on at the LHC at CERN, there's so many scientists from all over the world, many from the United States, from Switzerland, from France, you name it. So it's really important that we're all kind of speaking the same language. So on the left here, I have a table that have some of the fundamental physical quantities in physics. In the beginning of the year, we'll be concentrating with the first three here: length, mass, and time. Something that I want to point out here is that what I have on the right is the standard units that we use for each of these physical quantities. So you'll notice that length is going to be meters with this simple little m here, and that probably doesn't surprise you. Mass in kilograms might come as a surprise, because notice that this unit for kilograms is the only one in this whole series that has one of the metric prefixes. So a lot of people coming into physics from chemistry kind of might make an assumption that the standard unit of mass is grams, but it'll be kilograms here. So just something to keep in mind here. Time, our standard unit is seconds. And then for the rest of these, some of these will be familiar and some of these will be new. Temperature we deal in Kelvin, which is a capital K. Electric current will be in amperes, which is capital A. Luminous intensity we don't get too much into in AP Physics 1, but this is given as a candela. And the number of particles I know you're really familiar with coming out of chemistry, and of course that's the mole. So sometimes in problem solving that we would do in physics, it may require us to convert between units from time to time. On the AP Physics equation sheet, you'll probably be happy to know when we meet up in September that on the back of that sheet, it does go through the metric prefixes and tells you how they relate to the base unit, which I think is really useful. However, in terms of just time and being able to kind of move through these processes quicker and more efficiently, there's a number of things that I really need you to memorize. One of those is the time conversions. So just understanding, or kind of knowing by heart here, how many minutes in an hour, how many hours in a day, days in a year. And most people, kind of have that down. The next three conversion factors should be committed to memory as well. And I've kind of found in the past, if people have trouble thinking about millimeters and meters, or kilometers and meters, one of the things that I think is a good idea would be to kind of just envision a meter stick. And so if we envision a meter stick here where, these that we've used before in other classes, we can envision, okay, when I think about millimeters and I think about a meter stick, like, what's going on here? All right, well, I know that on a meter stick, I would see tons and tons of these little millimeters. You ever use a meter stick and find a kilometer? Probably not, right? So that tells us that in this case, the meter is the smaller unit. Whereas because we can envision millimeters on a meter stick, this one here, sorry about that, is the smaller unit. How about centimeters? Do they appear on a 1 meter stick? Yeah, definitely, right? So these centimeters are going to be the smaller of the two quantities. So what I would need is I'd need to commit to memory the conversion factors for these. So the question says, how many millimeters are in 1 meter? So for every 1 meter, there's 1,000 millimeters. Got to know it. And this same conversion factor could be written this way, right? I mean, there's 1,000 millimeters in every 1 meter. Okay, so what about kilometers? Well, I know that the meter here is going to be the smaller unit, so I have to ask myself, okay, in 1 kilometer, how many meters is that? All right, well, kilo means 1,000 also, just like millimeter. So there's 1,000 meters in 1 kilometer. And we can write this same conversion factor this way. There's 1,000 meters in 1 kilometer. And then what about centimeters in a meter? Okay, well, meter again is going to be the larger one in this case. So in every 1 meter, there's 100 centimeters. And I can write this way as well. 100 centimeters make up 1 meter. So these are the conversion factors that everybody must know to kind of get us started this year. Dimensional analysis, or the factor label method, really only consists of 3 main steps. You would write what you know on the left, and then leave yourself a ton of space before step 2, and then write the units that you're looking for. We can only write the units because we don't know the answer yet, so we're going to write the units of what we want to find on the right. And then step 3, we're going to write in a conversion factor in the middle that causes what we don't want, you know, what's showing up on the left here, to cancel out, and we'll put what we want in place. So we'll end up with the units that we've written on the right. Sometimes this requires more than one conversion factor, so we're going to go through a couple of examples here. Okay, so the first problem has us converting 2.4 meters to centimeters. So if we think about dimensional analysis, the first step is to write what we know on the left. So we know that we have 2.4 meters. All right, so first step's done. Next, we want to write the units of what we're looking for on the right. Well, it says to convert it to centimeters. So on the right here, put a little equal sign here, and then blank, because I don't know the answer yet. And I know that my answer needs to be in centimeters, though. Okay, so now I have to think about a conversion factor that I know that will allow this meter here to go away, to cancel, and will leave us with centimeters. So if I think about it, I have to think about, all right, does the meter go on the top? Does it go on the bottom? If I write meter on the top, I would end up having meter times meter, which would give me meter squared, and that's not what I see in the answer here. If I put meters on the bottom, then I would have meter divided by meter, which would just give me the number 1. That'll work out as long as on the top here I have centimeters. So even before I plug in numbers here for this conversion factor, I can see that a meter divided by a meter would just cancel out, would leave me with 1. And if I can get a conversion factor between centimeters and meters, I would have the units that I want. So I know that there's 100 centimeters in every 1 meter. So this ends up being 2.4 times 100. So it's just 240 centimeters. Okay, so the next example is 1 hour and 20 minutes, and we need to convert that to hours. Okay, the first thing that I have going on here is I have 1 hour and 20 minutes. So I basically have 2 units that are different than each other, so I wouldn't be able to kind of add those together to see what I have. So the first thing I'm going to do is I'm just going to think about this 1 hour is really just 60 minutes, right? So convert 60 minutes and 20 minutes, it's 80 minutes. So what I really have here is 80 minutes. And it's asking me to convert that to hours. So I've written what I know on the left, and now I'm going to write the units of what I'm trying to find. It's going to be hours on the right. So 80 minutes, and I'm trying to get hours. I'm going to put minutes on the bottom, because if I have minutes divided by minutes, they would cancel out. Do I have a conversion factor that can compare minutes to hours? Definitely, right? So for every 1 hour, there's 60 minutes. So now all I need to do is 80 divided by 60, and we've got about 1.33 hours. Okay, so at this point we're trying to convert between square meters and square centimeters. And I'm just kind of going to give everybody a tip here. This is where I see most of the mistakes when everybody comes in to physics here from chemistry. So really important to kind of know the difference between a centimeter and, let's say, a square centimeter. A square centimeter is centimeters squared. So it means at some point you had centimeter times centimeter. All right. In this problem, we have 122 meters squared. So that's what we know. So I'm going to write that over here. Okay. The units that we're trying to find are centimeters squared. So on the right, I'm going to have equals blank centimeters squared. And just by looking at this, I don't think it's going to be one step. I think this is going to be a couple of steps. So I left myself some extra room here. Now, a lot of people try and just put meters squared on the bottom here because they know that they don't want meters in their answer. Now, I don't know about you, but I have a lot of important things to remember, and one of those is really not these extra conversion factors like square meters to square centimeters. So for me, I just know that if I have meter squared on the top and meter on the bottom, I can kind of like get this party started here and start canceling out units because I know that a meter squared divided by a meter would get rid of that squared component and would get rid of this meter altogether. I like doing it this way because I don't need to remember any other conversion factors, and I think that it really kind of avoids some mistakes. So if I do this, I know that there's 100 centimeters for every 1 meter. The problem is, though, that if I leave this the way it is, I have meter times centimeter, and that's not the units I'm looking for, meter times centimeter. I'm looking for a centimeter squared. In order to get centimeters squared, I'd need to have centimeter times centimeters. And I also still have this problem of the meters over here. So if I do this again, 100 centimeters in every 1 meter, I notice that this meter divided by this meter cancels and leaves me with centimeter times centimeter, which is centimeter squared. So the units are all worked out. So now all I need to do is 122 times 100 times 100. And you get 1,220,000. Let me write it out for you. 1,220,000 centimeters squared. I hope that you found this quick review tutorial helpful, and good luck on your summer assignment.